Hello and welcome here at TEQnation 2021. For the next half hour, I'm going to discuss how virtual, augmented and mixed reality technologies can be used for other things than games, namely to facilitate training and working. My name is Saskia Groenewegen. I've been involved with virtual reality for a long time, since my student days in Germany. I think I first came across it working as a student at the Fraunhofer Institut für Medienkommunikation, where a lot of early VR research was happening. And I loved it so much that after graduating in computer science, I moved to Weimar to do another master's degree, just focusing on VR and AR. I also got to work with some brilliant VR and computer graphics researchers at TU Delft and TNO in the Netherlands. Spent some time as a PhD student at Utrecht University before then moving into industry R&D. And for the last 3 years, I've been working as a software architect at Ordina as the lead of the VR and AR team. You can see some pictures of my work here. And as you can see, it's really diverse. Like some days I'm on a high voltage station, and in other days I'm trying to get the cow not to eat my hardware. And sometimes I give talks, like today. So let me tell you a little bit about Ordina. Ordina is a local IT service provider in the Benelux with a little under 3,000 employees. The people who work there are mostly software developers. We do C#, Java, Python, Mendix, IoT, almost everything. Ordina was founded in 1973. We focus on realizing a digital head start for clients in the sectors of finance, government, and industry. And we do this by devising, building, and managing digital solutions. Ordina helps its customers to stay ahead of the challenges and changes in their business. Ordina has in total 9 offices in Belgium, the Netherlands, and Luxembourg. So within that rather large organization, there's the Ordina Extended Reality team that does immersive technologies, extended reality, XR, however you want to call it. And we've been doing this for quite a while. We've been, since 2014, so for 7 years, we've been working on over 50 projects for industry clients, for government, defense, healthcare, and education. So you can imagine it's really diverse work. Like one day we're on a ship of the Navy, and the next day maybe we're in a cowshed. And the XR team is a part of the Ordina Microsoft unit, because we do everything in C# and using the Unity game engine. When we speak of extended reality, what we mostly mean are the following 3 core technologies. We have virtual reality, mixed reality, and augmented reality. And virtual reality, as I'm sure most of you are aware of, replaces the entire real world with a simulated virtual environment. So you put on your VR glasses and you step into a different world. And you see 2 examples of that here. Popular games, Beat Saber and Job Simulator. And the technologies for VR range from like really simple cardboard boxes that you put your phone in to huge room scale installations that you can walk around in. And also VR is not just a visual aspect. Other technologies can be part of VR, haptics, smell, anything really that you can sense. Now with augmented reality, you do see the real world and you augment it by projecting information on top of it. And a very famous example for that is the game Pokemon Go. And you see 2 other examples here in the pictures. And for AR in this sense, you mostly use a mobile phone or a tablet. But there are also glasses like Google Glass, for example. Now, mixed reality is really similar to augmented reality. And the difference is that we use glasses with lots and lots of sensors, like the HoloLens or the Magic Leap. And through all of those sensors, the glasses know a lot more about their environment, which enables them to place digital objects into the real world just like they were real objects. Like you can take a digital coffee cup and place it on top of a real table, for example. And those digital objects look really realistic because they are three-dimensional and stereoscopic, and you can interact with them in a very intuitive manner by grabbing them with your hands, for example. You can even play piano in midair. So now you have an overview of the technologies we're using. And we saw a couple of examples for games where they're used. But at Ordina, we don't use XR to develop games. We use it mostly for two goals: to help people train and to support people during work. And we're not the only ones. We've seen in the last year or so a very distinct move of the whole industry towards more enterprise-focused solutions. For example, if you look at the hardware, several big hardware vendors have come out with headsets, especially for enterprise clients. We have the HoloLens 2, we have Google Glass Enterprise Edition 2, we have the Vive Pro, and even headsets that are very consumer-oriented, like the Oculus Quest, come with an enterprise version. And the reasons for that is that by using immersive technologies, enterprise clients can gain a lot of benefits. So where is that? To answer that question, we have to take a little step back and have a look at the situation on the labor market. And what we see there is the following. Despite Corona and previous years, we've in general had an economic growth. But at the same time, there's a lot of population aging, and that means we're losing a lot of people who retire. We're losing their skills and losing their knowledge. On the other side, we also see that people, especially technical people, become more and more specialized, which means they are not as widely employable as before. And lastly, we have an insufficient influx of younger people, which means that we don't get enough new young workers to replace the ones that we're losing through population aging and retirement. And as an example for that, a big Dutch company, ASML, they published a study that soon they will need every year as many engineers, as many new engineers as graduates in the entire country. So what this means is we have to do more with fewer people, and the fewer people we already have are becoming increasingly specialized. And those things together lead to a big labor shortage. So how can we solve this? Well, this is where emerging technologies can help. And the key word here is sustainable employability. We can use AR, VR, and MR to make people more widely employable. So here are the benefits that we see. For example, using VR, we can create realistic training environments that people can use when the actual environment is difficult to reach or really expensive. We can make knowledge more accessible. Think of using AR glasses to project information that would otherwise be in some backend system or in a manual. We can make people more widely employable by connecting them with their colleagues. We can also facilitate remote collaboration, and through the use of things like sensors and gamification, we can make the whole training or work experience more personal and more fun for the user. And all of this together leads to training and working that becomes more cost efficient and more time efficient. So these are the benefits that you can gain. The next question is, how do we get there? Well, by supporting two distinct use cases. helping people during the training phase, and helping people during the work phase. And in our experience, for the training part, the most useful technology in many cases is virtual reality, or what is also called immersive learning. And for working, the most useful technology, not always, but most often, are AR and mixed reality, or performance support. So, that was the theoretical part. Now let's have a look at some use cases that we have implemented for our clients in those areas. Let's start with virtual reality and immersive learning. This is the ship of the Royal Dutch Navy that's deployed in the Caribbean, usually busy with humanitarian missions. But that means that the ship is always far away, and if a new crew needs to be trained for the ship, they have to wait until the ship comes home. Then the ship has to lie in the harbor for 2 weeks while the crew trains and learns how to use and work on the ship. So what we did to help with the situation is we built a digital twin, a digital copy of the ship and some of its systems. So here you see the real ship. This is my colleague who did most of the programming on this project, putting on a VR headset, and then she steps into the virtual ship. As you can see, here's the real ship for comparison, and they look almost identical. You can look at all of the systems of the ship, familiarize yourself with them. We built the virtual ship based on CAD models of the real ship. Using the Vive controllers, you can interact with objects, you can move around, you can teleport. And in this way, you basically learn already where everything is on the ship and where it's located. And then we have this system with all the buttons, and every button here works exactly like it does on the real ship. Which means, you know, you can train using all of that without ever having seen the real thing. And we built this in 5 weeks with 2 people, 1 programmer and 1 3D modeler. So in general, those digital twins enable you to train with systems that are either hard to access or that are dangerous. Think of high energy systems or fire. And here are a couple of other benefits, right? It saves you time, it saves you cost, you can train location independent, even in your own house. You can repeat training way more often than you could on a real ship. This way the training also becomes more efficient and also safer, because it doesn't matter if you make mistakes, they're not going to hurt you or anyone else. So this virtual training environment was built for nursing students who go on to work as nurses in a military environment, and that are also often sent into war zones to treat patients. And this VR system is now part of their actual school curriculum, and it helps them learn triage and also clinical reasoning. But what it also does is put them through virtual reality in a situation that they would usually normally never encounter in their training in a regular hospital, right? It puts them into a field hospital in a war zone with patients who have injuries and symptoms that you usually don't encounter, like shot wounds or leg amputations. And this way they are much better prepared for their actual real work later. Here we see some pictures. Unfortunately, you do not hear the audio. Imagine shooting helicopters, all kinds of distracting sounds. Here they have to decide which patient needs their help the most. Bit of our environment, our patients looking not so good. And the students then collect all kinds of information about this patient. You can talk to the patients as well. And then here's all the information that they collected, and now they have to figure out which of this information is actually important to treat this patient. So here we have an example of remote collaboration. Imagine you have a team of people on different locations or even different countries, and you want them to work together. For example, because they're not allowed to physically be together in one office. So for the Dutch emergency services, we built this virtual environment that allows them to work together in a team of up to 20 people in virtual reality. And it's a briefing tool. And what it does is it has a big map of the country on a table, and on top of this map you can plot all the important information that you have. And they use this example to determine where to send their units or how to prepare. And one of the big strengths of the system is that it allows you to visually plot many different data sources that are not connected on top of each other, and so gain much better insight by seeing the connections visually in front of you. Imagine, for example, how the weather influences the traffic, things like that. And here we see a list of the benefits again. So the system saves you time and money because the people do not have to travel, and also because they can work faster because of the insights they gain. And they can remotely collaborate. That also means it's more eco-friendly because they don't have to use their cars. They're location independent, and also working this way for them is really fun. So these were some virtual reality examples. Now let's move on and look at some mixed reality solutions that we built for the Microsoft HoloLens. This little black ship is part of the bigger ship that we saw before. And the problem here is, or the challenge, is that this ship has a lot of different technical systems that all need to be repaired. But they can only take a small crew. They can only take, I think, 3 mechanics to repair all the systems on that ship, which means every mechanic has to be extremely widely employable. And to help them achieve that, we built this HoloLens solution. And imagine they have to repair one of those big motors on the ship. And what the HoloLens does is, firstly, it gives them instructions on where every part of this motor is located. Because imagine they can repair car motors, but they cannot repair ship motors, but they have kind of the same parts. So by giving them this, they already can orient themselves much better. And then the next step, it gives them step-by-step instructions and walks them through the solution by telling them where everything, and not just where everything is, but also what to do at that part, with which tool, with how much force, and in what order. And in this way, you can achieve much more with much fewer people. I'm now going to show you a video of the system, and I apologize, and it's only in Dutch, but it's basically telling you the same that I just explained to you.
Er is in Nederland een groeiend tekort aan technisch opgeleid personeel. Door de vergrijzing stroomt veel ervaren technisch personeel uit. Als er geen toename komt van jongeren die een technische opleiding volgen, zou dit tekort ieder jaar met 20.000 kunnen toenemen. Ook de Koninklijke Marine kampt met dit probleem. Aan boord van een marineschip is maar een beperkt aantal monteurs aanwezig. Er zijn echter veel verschillende machines en apparaten die onderhoud nodig hebben. Dit vereist een brede inzetbaarheid van het aanwezige technische personeel. We volgen een monteur die onderhoud gaat plegen aan de 2 dieselmotoren van een RIP. Een RIP is een zeer snelle, zeewaardige motorboot die een belangrijke ondersteunende functie heeft tijdens missies van de Koninklijke Marine. Het onderhouden van deze motoren vereist specialistische kennis. In plaats van de onderhoudshandleiding erbij te pakken, gebruikt de monteur een HoloLens. Ordina heeft in samenwerking met de Koninklijke Marine een augmented reality applicatie voor de HoloLens ontwikkeld. Met deze applicatie kun je onderzoeken hoe technisch personeel ondersteund kan worden bij specialistisch werk. Ook is het mogelijk om een overzicht van alle belangrijke onderdelen van een machine te laten zien. Een zeer geschikte optie voor opleidingsdoeleinden. Ondersteuning voor nieuwe machines kun je op eenvoudige wijze toevoegen. Tijdens het gekozen onderhoud worden er stap voor stap instructies op de juiste plaats bij de motor geprojecteerd. De teksten van de instructies worden verduidelijkt door middel van bewegende pijlen. Op deze manier is het mogelijk om handenvrij te werken en hoef je geen papieren handleiding te raadplegen. Het onderhoud is afgerond. De RIP is weer klaar om ingezet te worden. De voordelen van augmented reality voor monteurs. Visuele instructies maken het werk voor monteurs efficiënter, prettiger en veiliger. Monteurs zijn breder inzetbaar. Monteurs kunnen sneller zelfstandig aan de slag.
Again, apologies for the Dutch video. Here's a similar system that we built for energy company Alliander. And they're facing kind of a similar problem, because what they did is acquire lots of smaller competitors over the previous years, which now they're faced with a huge amount, but kind of similar, but different technical systems that they all have to take care of, with a limited amount of mechanics. So, same as for the ship before, this HoloLens app guides the mechanics to repairs. So the mechanic doesn't need to know all the details and can repair a much wider range of systems independently. And in addition to the previous solution, what you also have here is you can contact a colleague, say a more experienced senior colleague in a different location. Because how they used to work in this case was they would always send two people out to repair a system, a more senior person and a more junior person. But with the HoloLens, they don't have to do that anymore, because you can just, using the video chat function of the HoloLens, contact your colleague, who can then, through the video feed, see what you're doing and even draw instructions into your field of view, meaning this junior employee is can be sent out alone much faster, which means you can do way more with the people that you have. Here again a little summary. It saves time, it saves costs, you can collaborate remotely, people are way more efficient. It's also safer, because by giving you step-by-step instructions, you are less likely to make mistakes. Less travel, eco-friendly because of that, and of course, using the HoloLens, you can work hands-free. So here's a solution that we built for NADAP livestock management. NADAP makes software for farmers, and in this case for cow farmers. And the software collects a lot of data about every cow. For example, has the cow eaten? Is the cow healthy? Is the cow pregnant? What's the weight of the cow? There's a lot of data on every animal. So we built this HoloLens application, which visualizes the data and also lets you interact with the data, because a cow shed is not the most clean place. So what you do not want is to always, like with your maybe dirty fingers, take out your mobile phone and search for the cow that you want data on and look it up. So what this application does is it has geo information about every cow, so we can project the correct information over the correct cow. And it also allows you to work with your hands-free. And you can look the data up, you can browse and through the data, you can enter new data, and in this way interact with the data in a very intuitive way. It's always up to date, and you always have the correct data in the correct context. Let's have a little look at the video.
We've created an augmented reality experience that shows relevant animal information in your view. Actions that you perform are entered into our management system automatically. Depending on the task that you are performing, the system really thinks with you. May that task be a vet check? There's no need for a second person giving you information, and there's no administration afterwards entering treatment information into your computer. What makes this hands-free experience possible is the cow control technology that we've had for years now. We know the behavior and the location of all your cows, and we've combined it with this new augmented reality technology.
So that was some mixed reality projects. For my very last example, I want to show you an augmented reality solution, because mixed reality glasses like the HoloLens or the Magic Leap are really expensive, and not every project has the budget or the need for all that spatial information that those glasses provide. And often it's enough to just use the capabilities of your mobile phone. So this is a mobile phone application that we built for energy company Alliander. And we built it for mechanics who have to repair malfunctions on high energy assets. And how they used to repair them is by going into the house on that high energy station and searching through several books. It took quite a while to get the correct information about that asset. And to make this whole process faster, we built this app. And this app basically allows you to walk around outside, detect the correct asset, and it immediately displays all the information you need without you having to search for it. It also displays all kinds of history information, like what has been going on with that asset before, is there maybe any poisonous paint, anything else I have to pay attention to, and then it shows that application shows you all that data. And to detect the assets, we used a new technology from Microsoft called Spatial Anchors, which allows you to recognize assets without using markers or QR codes that you need to put somewhere to scan. And the asset just needs to be scanned once by your mobile device and then can be recognized by this or any other device without the use of markers. So the result of this is again that people are more widely employable because they are less dependent on specialists. They also know better what security measures are needed. There's a shorter lead time for malfunctions and less chance of mistakes. And that leads me to the conclusion of my talk. We've seen that immersive technologies like augmented, virtual and mixed realities have a lot of benefits for training and for education. They save time and cost, they make people work more efficient and also more safe because they make fewer mistakes. People can gain insight through data visualizations, they can work hands-free when necessary, can work location independent and collaborate remotely. They can repeat their training as often as they like without having to be at a physical location. It's more eco-friendly because people have to travel less, and in general, it is a lot of fun. To sum up how we got here is we wanted to make people more sustainably employable. We do this by supporting two things. Support them during the training and support them while they do their jobs. And we do this mostly through immersive training with virtual reality and through performance support with mixed and augmented reality. I want to conclude this talk with a little show reel of our work, and afterwards I'll be happy to answer your questions. Thank you very much.